Here's a question every EV shopper or owner wonders about. There is no simple answer, but knowing the variables will help you better estimate the time it takes for an EV fill-up. How long does it take to charge an electric car? Figuring precisely how long it takes to charge an electric car is akin to asking, how long does it take to cross the country? It depends on whether you're on a plane or on foot. Recharge time is dependent on a host of variables, many of them nuanced. Even the length of the charging cable can influence it, that make providing a precise answer impossible. But we can give you some reliable guidelines. Setting aside some of the minute variables, there are three major factors that impact EV charging time: the power source, the vehicle's charger capacity, and the battery size. Ambient conditions generally play a smaller part, though both cold and hot weather extremes can considerably increase charge time. Factors that affect charging time. Charger level. Let's start with the power source. Not all electrical outlets are created equal. The common 120-volt, 15-amp receptacle in a kitchen is to a 240-volt outlet that powers an electric dryer as a squirt gun is to a garden hose. All electric vehicles can, theoretically, charge their large batteries off the standard kitchen outlet, but imagine trying to fill a 55-gallon barrel with a squirt gun. Recharging an EV battery with a 120-volt source. These are categorized as Level 1 according to SAE J1772, a standard that engineers use to design EVs, is measured in days, not hours. If you own or plan to own an EV, you'll be wise to consider having a 240-volt Level 2 charging solution installed in your home. A typical Level 2 connection is 240 volts and 40 to 80 amps. While fewer amps is still considered Level 2, a 80-amp circuit will maximize most EVs' onboard chargers. More on those in a minute. Because, if you're not maximizing the effectiveness of the vehicle's onboard chargers, a lower than optimal power source is essentially a restrictor plate that lengthens the charge time. For the absolute fastest charging possible, you'll want to plug into a Level 3 connection, colloquially known as a DC fast charger. These are the EV equivalent of filling that barrel with a fire hose. A certifiably lethal current of DC power is pumped into the car's battery, and miles of range are added in short order. Tesla's V3 superchargers pump out up to 250 kilowatts, and Electrify America's automotive defibrillators fire out up to 350 kilowatts of heart-stopping power. But like all charging, the flow is throttled back when the vehicle battery's state of charge, SOC, is nearing full. And vehicles' ability to accept DC charging varies widely. The Porsche Taycan, for example, can charge at up to 320 kilowatts, while a Nissan Ariya can manage only 130 kilowatts. Using a fast charger. Generally speaking, when an EV battery's SOC is below 10% or above 80%, a DC fast charger's charging rate slows considerably. This optimizes battery life and limits the risk of overcharging. This is why, for example, manufacturers often claim that fast charging will get your EV's battery to 80% charge in 30 minutes. Some vehicles have a battery preconditioning procedure that ensures the battery is at optimum temperature for rapid charging while en route to a DC fast charger. So long as you utilize the in-car navigation system to get you there, that is. Maximum charging and driving range. That last 20% of charge may double the time you're hooked up to the fast charger. The time-consuming affair of completely filling the battery via a DC charger makes these units best utilized on those days when you are traveling a long distance and need additional electricity to reach your destination. Charging at home overnight, sometimes called top-up charging, is a better solution for getting the juice you'll need for daily, local driving. Battery size. As the hunt for range supremacy continues, the battery capacity of some EVs has ballooned to absurd levels. Others are targeting increased efficiency. This plays a massive role in charging time. Upsize our barrel to an 85-gallon unit. Even with a fire hose, it'll still take longer to fill than the smaller 55-gallon barrel. While a GMC Hummer EV is built on an architecture capable of 350 kilowatts intake, filling its 205.0 kilowatt-hour battery compared to the 112.0 kilowatt-hour pack found in a Lucid Air Grand Touring requires exponentially more time, even if the charging rate is similar. The Lucid can travel over 40% further on a charge while having 93.0 kilowatt-hour fewer in its battery pack than the Hummer. Efficiency, indeed. No doubt someday manufacturers will settle on a single metric for expressing charge times. But for now, know that filling up an EV's battery still takes considerably longer than topping off a gas-powered car's fuel tank, no matter how or where you do it. Charger capacity. There is a common misconception that the thing you plug into an electric car is the charger. In fact, there's a battery charger in the car that converts the AC electricity from the wall into DC electricity to charge the battery. Onboard chargers trickle power into the battery pack safely and have their own power ratings, typically in kilowatts. If a car has a 10.0 kW charger and a 100.0 kilowatt-hour battery pack, it would, in theory, take 10 hours to charge a fully depleted battery. To gauge the optimal charge time of a specific EV, you divide the battery capacity's kilowatt-hour number by the onboard charger's power rating, then add 10% because there are losses associated with charging. This is assuming the power source can maximize the vehicle's charger. Typical onboard chargers are at least 6.0 kilowatts, but some manufacturers offer nearly twice that, and the cream of the crop have more than triple that figure. The current Tesla Model 3 Performance, for instance, has an 11.5 kW charger, which can take full advantage of a 240-volt, 60-amp circuit to recharge its 80.8 kilowatt-hour battery, while the rear-wheel drive Model 3 comes with a 7.6 kW charger. Doing the recharge time math indicates that it will take nearly the same time to fill the two cars' batteries, though the performance models is roughly 30% larger. The beauty of a well-paired electricity source and onboard charger is that you can plug your EV in at home with a nearly depleted battery and have a fully charged steed waiting for you in the morning. You can also find approximate recharge times on some EV manufacturers' websites. All told, there are a wide range of possibilities when answering the question of how long it takes to charge an EV. In our testing, we've observed DC fast charging times as low as 25 minutes from 10 to 90% in a Porsche Taycan prototype, and as high as 2 hours in a GMC Hummer EV SUV, while the average sits just shy of an hour. Hyundai Ioniq 6 at a Tesla charging station. For Level 2 connections, the time variation is much more dramatic. The Lucid Air Pure is the quickest from 0 to 100% at a smidge more than 5 hours, and the longest is the Nissan Ariya at over 13 hours, while the average falls in the 7 to 8 hour range. And even though 13 hours feels excessive, because it is, the Ariya is still capable of charging from fully depleted to fully charged after a typical 9 to 5 with an appropriately powerful source of electricity. Like what you just watched. Subscribe to our YouTube channel for engaging articles, exclusive content, and the latest updates.